Hey, this is Jody with weldingtipsandtricks.com with another weekly video. I just got back from a little shopping trip at Harbor Freight. Who doesn't like to go to Harbor Freight? Well, I'll tell you who. My wife doesn't like to go to Harbor Freight, so I went alone today so I could just kill as much time as I felt like. And I wound up buying a handful of things, and some more things jumped in my cart, and I put some things back. But anyway, sometimes I gotta go to Harbor Freight just because I'm scratching my head, going like, "What's this week's video going to be about?" Oh crap! I don't really have anything going this week. So, I do one every week. That's kind of the plan now. So sometimes it helps me to walk through the aisles of Harbor Freight. Gives me ideas, and then those ideas give me other ideas. Next thing you know, my evil mind has come up with a video. The main thing that I scored today is called a welding spoon. What's a welding spoon? Well, let me tell you what it's not. It's not what lonely welders do. This is a welding spoon. Normally I think this is used for holding with one hand while you hold a MIG welder with the other to fill in drilled out spot welds in auto body panels, and it would work really good for that. But today we're going to use it to fill in some holes in stainless steel. We're going to use it for backing instead of argon. $9. I mean, it's kind of hard to go wrong, and that's what I ask myself when I'm buying things from Harbor Freight is what can go wrong here. And if I have too many answers to the question, I put it back on the shelf. So this is a piece of copper soldered or welded to a steel handle with a rubber grip on it. I just don't see a whole lot that can go wrong here. I ordered what was supposed to be some copper scouring pads online a while back, and they wound up being copper plated steel. And so I'm a little bit leery all the time when I see something that's advertised as copper. So I put a magnet on this even while I was at Harbor Freight. I used one of their magnets that they had on the shelf to make sure it wasn't copper plated steel. And sure enough, it's a solid piece of copper fastened to a steel handle. And so to me, that's pretty good. That's about 1/8 inch or 3 millimeter thick copper. It's nice and polished. Could make one my own, of course, if I go to the scrap yard, scrounge up a piece of copper, or I could get some copper tubing at Home Depot and just flatten it and tack weld a little handle on it. No problem there. But for $9, it's done. I just unwrapped it and it's done, and it's pretty nice. Pretty nice actually. Okay, let's put the welding spoon to the test now. Okay, what we got here is some 18 gauge stainless steel with some 1/4 inch holes drilled in it. I'm going to weld one with nothing on the back side, no backup gas, just it's going to be exposed to the air. And if you've ever welded stainless steel, you can guess how that's going to come out. But for the demonstration, we need something to compare everything to, so I'm going to do one like that. And I'm going to do one with the welding spoon, the copper clamped really tight to the back of it. And then I'm going to do one with argon backing gas using a little deal I call a backup box. And it's just a purge box. It's got some perforated copper, but it's attached to an argon hose going to the flow meter. And so we'll get argon shielding on the back side of one of these holes, copper shielding on the back side of another one, and no shielding at all on the back side of another one. When you are filling a hole like this, it's probably best to hold the torch straight up and down. Now I'm using a number 8 gas lens here, and gas lens does help with a hole, and whether or not you're using backing. And but it's best to hold the torch straight up and down. You can cock it a little bit to get a better line of sight, but the gas lens does let you extend the electrode out a little bit further either way and see the puddle better, and gets better coverage also. Now, very low amperage here. I'm just running a little bead around the edge rather than trying to fill it in first. Add a little thickness to the edge there, and then I can add a little bit more amperage. Now, it only took about 40 amps or so without any copper or anything clamped to the back side of this thing. And that was 40 amps at max, like right about here. So using the foot pedal, I had the machine set on 40 or 45 and didn't max it out really until I got to the heaviest part of it. And so that hole is filled in now. And I'm a little bit, not too happy about the way the back side is going to look, but it's part of the demo. Next up, we're going to weld one with the welding spoon here. So copper backing right against the back side. Now the copper backing is going to do 3 things. Number 1, it's going to chill. It's going to provide quite a heat sink. Number 2, it's going to trap the argon, gas, so it's going to provide some amount of shielding to the backside. And number three, it's kind of going to cast the molten metal like a mold. So the molten metal can only go so far, and it's going to sink and rest against that copper, and so it's not going to be protruding through a whole lot. Actually, if you were going to grind this off flush and expect it to be 100% full thickness, it'd be good to burr a little divot or take a drill bit and just drill just a little sort of a countersunk hole just a few thousandths deep, and that would let the weld metal sink in there. So that's what it looks like against the copper. And that weld was done with straight current, no pulse or anything. Now, you've heard me talk about the rule of 33. If you haven't, here's what it is. It's 33 pulses a second, 33% on-time pulse, and 33% background current. And for welding on an edge like this, it really helps. It really helps confine the heat, keep it from melting away. And anytime you're welding on an edge or want to limit heat, the rule of 33 really does help a lot. So that's what I'm doing right here. I've got it set. It looks like it's a lot slower, but that's the shutter speed of the camera. But it's helping me make a little bit narrower fill, and it's helping me actually fill it in a little bit quicker. And when I taper off here, I always swirl the arc a little bit just to add a habit to avoid a crater hole. Okay, now next up we're going to use this little backup box. Now, in future videos I will show how to make one of these, but I got them in all shapes and sizes for different applications, for inside corners and outside corners and radius things and everything. And at a previous job we used to just stop and make one if we had to for a certain shape of a part, and it was worth it to get it done. So I've got this little kind of all-purpose one here. This is a really handy size to have. It's about a 2 by 3 inch perforated copper on the outside. Inside there's some diffuser material and a piece of stainless tubing that runs the whole length of the thing with holes cut in it where the argon blows to the back side and then comes up through the diffuser material and then up through the perforated copper. And I'm going to hook an argon hose to this from my flow meter. I've got a dual flow meter set up on the torch for applications like this. So I'm going to attach the little flex hose here to the 1/4 inch tubing. I'm going to turn the argon flow on just probably about 15 CFH. And I didn't get an arc shot of this particular weld, but it looks just like exactly like the rest of them. And that's what the backside looks like when shielded with the argon backup box. This is what sugaring looks like with no shielding at all, with it exposed to air. And this is what it looks like when it had copper backup on it. Almost as good as this, but not quite. So argon shielding is the best. Next best is copper backing. And the worst is the no backing, just exposed to air, where you got this granulation and sugaring. Now, even if you try to grind that sugaring off, I mean, you can grind most of it off, but it's got deep pits and crevices and everything, and that's where bacteria will grow if you're doing food service stuff. And you got pits there. You just can't really get it out unless you take almost all the thickness away. But if you're grinding one that's backed up with copper, you get something pretty nice. You don't have to take it down hardly to barely to flush, and then it's nice. So there's a few other things that jumped into my basket while I was at Harbor Freight. Let me show you what I got. Magnetic paper towel holder. All right. Sometimes the top of my toolbox is a mess. I got a belt sander, a bench grinder, a straight grinder, a bottle of beer, a coffee cup, a roll of paper towels, and a lot of other crap. You see the way you see this pegboard back here? Does this look like it's all organized in a place for everything and everything in its place? No, that's not. I wish I was like that. I wish I was more like that, but things get out of hand on me, and then I have to just do a big cleanup, and it gets out of hand. I want to keep working, and I hate to stop and clean as I go. It's been a lifelong struggle, but it is what it is. So I know I've got paper towel holder. This was $7 or $8, I don't know, but it's a couple of pieces that'll stick on my toolbox. It's a magnetic paper towel holder, and all I got to do is stick one piece up there, put the paper towel roll on there, and stick the other piece up there. Done. Love it. And that brings me to this. Now, why do I need paper towels in a shop? I'm all the time having to wipe stuff down with acetone. Filler rods, plates, things I'm going to weld. Box 100 extra large nitrile gloves for not getting acetone into my liver. There's enough things get into my liver without acetone. You know what I'm saying? All right. Little part of me dies every time I hear that sound. Another thing that jumped in my cart was these dial scribers. You know, when they cost 20 bucks and they come from Harbor Freight, they're going to be dial scribers. It's very handy sometimes to just be able to scribe a line with the hardened point on dial calipers. But you know, I don't want to spend the money for a good set of Starrett calipers and then be rubbing them all over metal and scribing. But I don't mind doing it with stuff I got at Harbor Freight. And you know what? Honestly, I've had really good luck with these before. You know, they're not going to be as accurate as a Starrett or some of the other more expensive brands. But if I want to scribe a line, say the center of that hole or something like that, at 20 bucks, these are a consumable. All right. So, and also got the dial, the old school dial kind, just because I don't want to worry about batteries ever or anything like that, because I am strictly as a welder and not a machinist. I'm not worried about, you know, tenths of thousands and things like that usually. So I'm looking at this and it's about 48 thousandths, which means it's about 18 gauge. So a stand like this, again, what could go wrong with this thing? Not a lot. I might be wrong, but you know, I don't want to take my time and materials and everything welding up one of these for when I can get one for 30 bucks. All right. And that's what it costs, 30 bucks. That all came up to somewhere around 60 or 70 bucks. So how did I spend 127 bucks then? That's how they get you. But remember, since this is a TIG welding video, remember that there are three main things that you're going to do wrong when you're learning how to TIG weld. And that's too long an arc, too much angle, and not shielding the tip of that rod. And here's what happens when you do all three. The heat is just not getting down into the corner of this little lap joint here. It's melting the top corner, it's melting the bottom, it's boomerang shaping, but it's not getting where it needs to go. It's not flowing right. There's crud flowing around in the puddle. Didn't change a thing. Didn't increase the amperage or turn it down or anything. And all I did was tighten up the arc length, tighten up the torch angle, and shield the tip of the rod, and you can see how much better it's going. Okay, well, before I say goodbye for this week, this is just a reminder that I put all my videos every year that I post onto a 4-disc set of DVDs, and this is what it looks like. And they're indexed really nice on 4 discs. It takes 4 discs to put them on because there's almost 8 hours worth of content on there because it's a whole year's worth of videos. There's a nice menu on the very back telling exactly which videos are on each disc. So if you're interested in this, go to weldmongerstore.com. Hey, thanks for watching. We'll see you next week.